through the initial workflow that we like to adopt here at CYPE. This diagram does a great job in explaining that. Now, of course, we have our physical 3D modeler. Now, this physical 3D modeler can either be, that model can either be developed in your own native software, such as Revit, ArchiCAD, etc. And then you can actually use our solutions to bring in those models into our workflow, this workflow here. Now, once we have that, or you could just use our IFC Builder program, and I'll show you guys where to download that if you guys want to. It's for free to use. Now, once that becomes a part of that shared information, we now store it in the BIMserver.center, and we'll have a look at that in just a moment. Then once that model becomes available to all other stakeholders within the project, and also in the cloud, of course, then we can use our specialist tools to model our programs and different layers upon that architectural model. So I'm talking about our structural programs, our energy programs, HVAC, fire design, everything. So we've really got a large extent of solutions to cater to sort of construction needs. Now, of course, all our programs are able to produce these technical documents, and these technical documents you can see here at the bottom, specifications, drawings, and reports as well. And those reports can also be attributed to different models that we model on our project, and also obtained through the BIMserver.center. And let's have a look here. So that's basically what I'm trying to establish here. Let's have a look at an example project. This is the BIMserver.center. Now, if you guys didn't know how to create an account, it's fine. Just go to BIMserver.center. It's free to create an account. And also, there are some programs such as our IFC Builder program that you can actually download for free. So we can come over here to projects. I can show you guys one example project. Now you can see here, we can open up this Crown Halls project. I have been having some issues with the internet, but it seems to be working fine today. There was some issues where opening up GoToWebinar, the program we use for this to deliver this webinar, and also the internet was lagging, but that's fine. It seems here that we've got it. So you can see here, this is an example project, and what I want to establish is this basic diagram on this project. Now you can see the architectural model, the physical 3D model, that can be viewed by simply toggling the architectural model here. I can turn off the structural model, and you can see that's just the architectural model. So we would have started our project with the architectural model, of course, either from bringing it in from our native software, IFC Builder, or of course, all the others. And you can see, we'll have a look at the store where we can actually download our uploaders and our plugins to bring in, like for instance, our Revit plugin. You can download that from the store here on BIMserver.center, and that plugin will obviously show up in your Revit program on your computer, and then you can, just by a click of a button, make it accessible to the BIMserver.center, and then of course start laying on your models with our inherent programs here. Now let's have a look. There are different models. Let's turn off that architectural model. You can see, we can make it transparent so we can view it. Now you can see furniture, and then the list goes on. Now this isn't obviously a completed project, but it does have some pivotal models. So our plumbing, our lighting, our structural, they're all, and you can see how it works, layer upon layer, and I'm able to select the different layers that I want to view, and also view how they interact with each other. And you can see here, this basically demonstrates the interoperability between programs. We can have our HVAC specialist constantly making changes, and those changes will be updated live on the BIMserver.center, so that our structural engineer or someone who's another stakeholder in the program is able to get live updates on the changes. And you can see here even the latest changes that you can view here. Now this project hasn't been touched for a while, so you can just see people getting invited to view the project, etc., etc. The other powerful tool, of course, I mentioned was the technical documents here. Now, what I've just demonstrated here is all the different types of specialized tools that are able to be attributed to one architectural model here. So quite a nifty sort of workflow that basically has reduced a lot of wasted time, increased design time, and we know what happens when we increase design time on an overall project. We get a better project when our engineers and our designers can spend more time on innovative solutions as opposed to trying to obtain documents, etc., etc. Now, on that point, trying to obtain documents, that was quite a point of contention for previous methodologies for construction, where the construction manager had to obtain documents from different specialists, etc., etc. Here, no, it's literally just right here in the Files tab. We can obtain all the different files from all the. It's just a plane going past, sorry about that. We can obtain all the different files attributed to different models here, and basically quite easily download them straight off the BIMserver.center. So all in one place, easily attributable, and also that interoperability is there with the solutions as well. Now, I just want to show you just some brief projects that I've been a part of. You can see here the level of detail can go quite deep, where we can actually model the surrounding grounds and the topography of that specific location, and then looking at different shape structures, as well as all the different types of models that we can attribute to our project as well, and even some in situ scenarios that we can define as well. Now, in terms of today's webinar, we're going to be looking at box culverts. Now, box culverts, of course, is a specialist program that deals just with box culverts. It's not something that we can attribute different elements to, but of course, it's a very specialist program. Now, if you guys are actually interested in downloading the program, you can get all the sorts of information either from the BIMserver.center, where you can look at all the different programs that are available for download. You can see here the program I mentioned that I'd actually encourage you guys all to download if you haven't, is the IFC Builder. And you can see by downloading this program, it's quite a very straightforward, easy to use architectural modeler, and that'll actually bridge you into connecting the different sorts of solutions. Because, for instance, you can, of course, create your own models without an architectural model. But of course, if you do have that architectural model, then everything fits together better, because you have that architectural model as a base design for your specialized tools as well. Now, of course, I'd highly suggest you guys to browse the store and view all the different solutions we have. Now, in terms of today's webinar, we're working on box culverts. If you guys wanted to read more about the sort of limitations and also capabilities of our programs in box culverts, I would highly suggest you come over to boxculverts.en.cype.com and read the different features we have. Now, just briefing over the things we're going to go through. Of course, inbuilt into the program is the assistants. Now, these assistants basically give us a basic method to model the different needs of our design. Now, we don't actually have to use assistants. We can, of course, create a box culvert from scratch, and we can also create it from our DXF and DWG files as well. So if you do have those files, you can import them and then model your design on those templates as well. Now, of course, all the different additions as well. So our models additions, there's also wing walls that we can add, 3D views, the different types of loads that are attributed to the program as well. So you can see, we'll go through this in a bit. We have some design models and checks that come from the implementation of different concrete codes. Now we're talking about reinforced concrete. So this is the list of the implemented codes as of today into the program. Now, if you don't have that specific code and you're interested in using the program, contact us. And of course, we've done this before where we can actually implement specific codes if the case is there for it. And then, of course, inherent to all our programs is the reports and drawings. So this is quite a powerful tool where we can design reports and design those drawings for our stakeholders and for our clients as well. So quite a sort of robust program that we can design box culverts in. Now, a limitation here, let's open up box culverts and come over here. Now you can see, if I come to structures, box culverts, for the design and check of reinforced concrete box culverts, rectangular or trapezoid, single or multiple cells. Now, rectangular or trapezoid, those are the key words there. We don't deal with circular box culverts, strictly rectangular or trapezoid. Now, of course, let's open it up and just view the type of environment that we work with, and also view some examples that have been attributed to this software. Now, of course, all our programs are basically designed very similarly in a way that you won't need to learn something or learn the environment every time you open up a different software. Let's create a new project. We can, of course, open up some projects that we've made in the past and also some examples, and we'll have a look at some examples as well later on in the webinar. You can see here the help documentation as well. So if you guys already do have box culverts, the program, don't be afraid to look at the user manual. Now, I know most of the time these user manuals are long and tedious, but actually I think by reading the user manual for box culverts, it's quite a simplified version, because it's not a very complicated software. It gets the job done, and there is some great benefits into reading the user manual here. But of course, we have our support team as well that's more than happy to help you guys. So let's create a new project. Let's call this the example webinar. Let's accept, and then we get a dialog box. If you create a new project with the assistant, the program will generate the data necessarily to describe it. Now, we can of course create a empty job where we would have to define each component of our box culvert individually. So I'm talking about the head wall, the link slab, our own individual box culverts, etc., etc. We can do that, but then of course we also have the assistants as well. So you can see here that the assistants, there's three types of assistants here. So we have an assistant for a straight culvert, a skewed culvert, or a general culvert. Now, you can see here, a general culvert basically means we can define the angle of the walls. A straight culvert, of course, is at 90 degrees, and skewed, you can see here, we can create any joint at an angle with that lateral wall. So let's have a look at the skewed culvert. I'm going to look at the assistant here. So I'm not going to create a new project. I'm just going to use the assistant and basically show you guys the type of workflow that we'd have to distribute. Now here you can see the program makes it quite easy to define this sort of design. You can see here that the example diagram is given with all the attributed lengths and values here, and then we basically are just required to create the culvert using this sort of geometry. So we can see here our internal height, our internal height, let's leave it at 5. Our clear span, which is our LI, we can of course leave it at, we can put it at 6. Our internal left initial length, so this here, we can just leave those at 3, 4, and 4, 3 for those simultaneously, so we get a trapezoid shape. Next, you can see here now we've finished our geometry. We move on to our wing walls. Now, previously we said that we can define the angles within our wing walls. You can see here, angle with lateral wall or angle with joint. And you can see this here is the lateral wall diagram, and this here is the lateral wall joint. And you can see I'm able to attribute certain angles to this as well. So we can leave this all at 45. Let's see how this goes. And also have the option to select whether it's perpendicular or extended on the wing wall. You can see, so either perpendicular or extended. So depending on which way we measure the angle. Then we get some options to amend the top roadway. Now, basically what this means is we have to attribute a certain height of soil on top of our fill on top of our box culvert. Now the program gives you the axis coordinate of that particular roadway. So of course, by using the assistant, you can of course work alongside your diagrams, your CAD diagrams. But then of course, if you don't have access to those, you can just use the assistant instead of creating a totally new project. So it's really up to you in terms of the way you want to progress through the workflow. So top roadway, let's give this a axis coordinate of about let's say 0.5 meters. The angle, let's say it's about 8 degrees. The width of the road, so we can say the general shows 3 meters, so let's say 6.2. Height above slab. Now, basically what this means is if we go back, again, you can see here that I've attributed the height of the internal height as 5 meters. Now, if we come back together, I would of course need to compensate for that 5 meters, and that's from the bottom of the reinforcement to the top of the reinforcement is 5 meters. So I would need to allow for extra here. Now, of course, I'm just guessing and using the assistant to get a rough idea of the design. But of course, there are certain calculations that you can do if you are, of course, a professional civil engineer, where you can calculate the load-bearing stress and actually calculate how much topsoil you would need, how much fill soil you would need to compensate for the box culvert. So let's leave this as 7 meters. Let's click next, and then of course we have our soil definition. So here you can see the soil definition is split up in 2, and that's just the capabilities there. We don't deal with more than 2 types of soil, just the base soil and the infill type. You can see here you have a selection between different types of fills. So I'm going to leave the base type as a medium dense sand and the top as a loose sand, or maybe loose sand's fine. Leave the slope angle as 26, of course, but that's from your different designs. We can come over here and get a brief description of the slope angle if you guys were not wary of the slope angle here. We can click next, and then we of course can generate our loads. Now, you can see here the types of codes that have been implemented and the type of truck load or uniform distributed load that we can attribute to this road above our box culvert. Now, you can see here the IAP 98, the RSA class 1, 2, and then some other codes here. I'm going to leave it as the IAP 98. Basically, it's quite a similar distribution. What it is just taking into account the different types of trucks that reside, and also selecting the worst case or the heaviest sort of truck that you can generate some point loads on the top road here. Now, of course, we can introduce a surcharge on the bottom slab as well. So if we had things like water, if we had a roadway within our box culvert, a train, etc., we can define those here. I'm going to leave it at 0.4 ton per meter squared because I don't have any other options. Of course, now if we wanted to do it, if we wanted to specify a liquid, we would of course have to obviously do those calculations ourselves, find the charge, and then input that within the assistant. So the assistant does take you to a certain level, but it won't teach you how to design the box culvert. And here we go. You can see the assistant has designed it for us. You can see the initial left wall, the initial right wall, final wing wall, and final left ring wall here. You can see the origin that's been placed here, which is fine. We can obviously change those as well using some different options that we have. Let's have a look at the type of workflow that we that are going to place with. We have our file tab. Now this is where we can save and distribute our projects, and also report. We also generate some reports and drawings that we can do. Moving on, our projects tab, we can define the materials. Now these materials have been taken from the selected code that we defined prior on the startup. We can of course change the type of concrete that we want to use, the steel grade as well, and also the type of environment. So the different type of environment that we want to attribute to this box culvert, depending on the road use, the location, the type of loads, the scale as well. So you'd have to refer to your individual codes that have been implemented here to select the appropriate one. Moving on, we have our general data tab. Now this general data tab, of course, would need to be attributed before making any addition. Initially, we start off with our ground description, so our subgrade modulus, allowable bearing pressure, our soil. Now, of course, this soil has been taken from the soil that we specified prior, and you can see here the fill as well. We can introduce cohesion factors. If I come over here to this blue arrow here, what this basically means is that there's a library underneath this arrow. And we can come over here, and of course we get the typical project values for our different soil types. So of course, with the different cohesion factors, the friction angles, and also the densities as well. Then of course, there's the geometry. So we can define the module of the top plane, either by soil thickness or by height, and we already defined that as 5. Lateral wall adjustments, we can make those lateral wall adjustments, and then of course our load. So we can of course introduce a bottom uniform load, a top uniform load. You can see the top uniform load located on the top road plane and of infinite extension. So this would be combined as an incompatible load with truck loads and strip loads. So these top uniform loads, of course, things like the actual road, so the actual gravel, asphalt, etc., that we can define here. We've just left that as 0.1 tons per meter squared. The bottom uniform load and also hydraulic surcharge, and we can also define those by depth as well and by constant level. So you can see here the sort of the program takes into account all different types of scenarios in which this box culvert can exist in the real world. Now, I did mention, if you guys had any questions, don't be afraid to ask. I'll try my best to address those. And if I can't do it at the time, because it's a difficult question, I'll leave it to the end and we'll go through that. But of course, if it's just a general question about the workflow, I can answer that to the best of my ability as I go on. Moving on, with our reinforced concrete parameters as well, we can of course attribute extended cover, external cover, internal cover, and maximum grain size for those concrete parameters. You can of course change that. Moving on, we have some other options as well. Now, in terms of reinforcement strip lengths, I've chosen to analyze by geometric disposition, but of course you have different options here. So you can of course analyze by strip length optimization. So if you wanted to optimize that load length, you can do that here. And also the last option with the reinforcement without additional reinforcement strips. So you can of course, when we deal with when we come into analysis and we analyze this structure, we can of course attribute some design tools and some design options for our design. Minimum percentage compliance for slabs. Now, of course, I can attribute our safety factors here, and of course all the different types of other options we have. So sliding, wing walls for overhanging, etc., etc. We can define those and change those either by turning off the option or not. Percentage cutoffs for detailing as well, I've left it as 10%. We can of course, a great option here is that we can make our default settings the ones that we change, so we don't actually have to change it every time we use the software. But that's a little nifty tool by selecting this, save as default settings, and then by clicking accept, these specific options will save. So for the next time you use the program, they're all there. We can of course look at our reinforcement. So our reinforcement in modules, so the different types of modules that we have here. The modules internally, by attributing the spaces and available diameters of those reinforcement bars. Another thing I wanted to mention here was, of course, we have our admissible diameters. Now, these have been taken from the code, but of course, I can select the ones that we do want to use or we do want to take into account when we define, but I can turn that off as well if I wanted to. So if we were dealing with only a handful of different diameters of reinforcement, we can of course make those changes here. And then alongside with the spacings as well. So we can add the type of spacing that we want and attribute the type of between 2 and 45 here, of course. So we can leave it as 40 or I can just delete it. So that's for our spacings. Now another great tool is the ability to, just like we did prior, the ability to save the specific work onto our local drive. And this brings into account these 4 buttons here, especially these 2 here. I can export our options to our work directory and basically create a library of different materials and different specifications that at a later date I can use again quite easily, that I'd be able to import. And you can see I don't have any actual library of files here because I haven't saved any. But if I wanted to, I can export spacings used box Culvert. Accept. Do you wish to mark the data as initial values for when creating new jobs? Yes. Export finished. I come over here to import, and you can see that file is now attributed here. I can select that, accept, do I wish to use, and those same modules have been inserted now. And this is for quite a small program, a small option, but this option here is rampant through our whole solutions, which is a great point to take into account. Of course, we can define all the different types of reinforcement. So in our footings, in our horizontal reinforcement, in our wing walls, etc., etc. We can of course conduct the 3D view as well, consult the 3D view. You can see here, we're able to view the box culvert in 3D. You can see the top layer, that's our road, that's our distributed load, our UDL, that we can view as well. We can come over here to some background. We can obviously change the background color, etc. Introduce the ground level, different materials, object edges. Now this is a very simple project that we won't actually can't view the full potential of the 3D view because we don't have many layers. But of course you can see all the different types of projection that we can do to the wing walls, to the design, sorry. So different projection types, different ways to view the project. So we can cut it in different axes, of course. These are some nice nifty tools for when We're analyzing the design by looking at different options to view, etc., etc. So for different access as well. Then we go into our free editing options. Now, these are all the different types of editing options that we can attribute to. Now, you can see here that I can, of course, create new left lateral walls, new right lateral walls, all these different types of components of our box culvert I'm able to delete, edit, and this is where we can do it here on our plan tab. So you can see here, I'm able to delete this particular left lateral wall. I can come over here to new left lateral wall. Oh, sorry, go back. So left wing wall, coming over to here, you can see I can delete this one and come over to plan and insert a new left one, wasn't it? All right, new. A new left lateral wall. Oh, my bad. What happened there? Oh, I don't know why that's happening. Let's go back. If I wanted to define the left lateral wall coming over to plan, move lateral wall point. Okay, yeah, so by doing this, I can of course move the different types of points and define the type of lateral wall that I want and also the internal box structure here. Moving on, we can of course move and amend different joints as I just did as well, internally and externally as well, depending on the type of structure that we have. Now, of course, if we had a type of a DWG or drawing file, I'm able to attribute those here. So I can come over here to edit templates. Now this is the templates view manager. I'm able to add, I don't actually have one right now at the moment, but I can add the template here. And upon adding the template, I'm able to, of course, select the visible region for that template, look at the type of imports that I can do for that template, and then, of course, model my box culvert internally as well. Now moving on, we of course can attribute different levels as well. So when we're looking at the heights as well, we can attribute new levels to the program. So you can see here the top level and bottom level, I've attributed that already to 7 meters. I can of course amend that as well. So I can introduce it and define it if I wanted to change it. So these options are all here for us. The geometry as well. Now I can amend the geometry of each individual component. This is what I should have done before when I introduced it, by simply selecting it, and then I get the options to amend the internal wing walls here. So you can see the diagram that's been given to me. So all the different values and corresponding lengths I can attribute and change here as well. Along with the footing, immediate sections as well, I can add those immediate sections if I wanted to, and also introduce those overhangs as well. And also define the ground surcharge as well, if we had different surcharges on different wing walls that I can attribute here. I can of course change the module geometry as well. I can add divisions internally. So here you can see if I add a division to the left wing wall, let's leave it, yeah, that's fine. I just want to demonstrate it. You can see here the division that's been done. And come over here to 3D view. And we'll be able to see the type of divisions that we can introduce in our box module. And then we move on to loads. So there's two options here. We can introduce a truck load, and or we can introduce strip loads, depending on the type of code that's been introduced and the type of use that this box culvert will be attributed to in the environment. You can see here that I have already introduced two type of loads. Now that was prior when we selected the origin and we selected those use cases for our example. And you can see here the truck load from that IAP 98, the number of positions covered by the truck. I can amend that. I can of course look at the, so this is a 10.2 ton truck with 6 wheels. I can of course edit these and edit the positioning of the wheels and the geometry, etc., and the type of loads as well that I can edit here. And also I can add different values if I wanted to as well, numbers of wheels, etc., etc. And you can see the sort of capabilities that inherit with the program. You can see here, this is a more nifty tool in regards to the export and import of those values. I can of course design my truck. Now of course, if you don't have those specific, if we haven't covered the specific code from your region in the software, it doesn't really matter. The sort of manual, the manual input of those specifications that haven't been covered, that are from your code, they can all be saved onto your library, onto your internal library by using these export and import to library features within the program. So you don't actually have to select those codes all the time. You just need to come in, import from your library the type of trucks, etc., the type of soil, the codes that have been attributed, the rules, and then you can progress forward with the program. I can of course create a whole new type of truck load as well if I wanted to. In terms of, I can of course have the option to move, delete, etc. And then of course, along with truck loads, we can attribute strip loads as well. So you can see I do have a strip load here. I can of course create a new one if I wanted to, but then I can of course edit, edit the truck load here as well. So you can see 6.2 meters, the width, and the load 0.4, and that's the full length of a strip load that we need to. About the strip load functionality. Now, you can see here the final bit is the analysis tab. Now, what I'm going to do is now open up some examples and then do some analysis. But you can see here the type of analysis we can do. We can check. So you can see this is all undefined and incompatible because I played around with it. And so I can of course design as well. This would actually give the program the ability to make changes for me and satisfy all the code rules and best practice values that I'd need to attribute to different components in the wing walls and also in my central modulus. So let's have a look. The last thing what I'm going to do is open up a few examples. Now we do have some examples, and this will actually demonstrate the sort of breadth of different designs we can attribute. So coming over here to File Manager, Examples. Now, of course, if you do have this program, you can view all these examples. Let's quickly run through them, and then on the last one, we can do some analysis and actually show you guys the full potential when we're looking at analysis. So this is a simple a wing wall with two lateral cuts as such. So not taking into consideration any wing walls, etc. Just a single box module. The next one is a culvert with trapezoid section, so something similar that we've done in today's webinar. So you can see here, so we can introduce different angles, of course, to model with the ground. Underground passage with 5 modules here. So we can, of course, a nifty feature is we can connect different modules and define different angles as well, so we can, of course, get a larger fulfilling module here. So you can see here with 2 lateral cuts with 5 different separate indentations, or 5 different, turn that off, we can material object edges. And you can see here that I can view those different modules independently as well if I wanted to. So this one is a single module with a 0.1 by 0.1 10-ton point load. We can actually view the point load as well. So I can come over here to truck loads, edit, and you can see here, this is the point load that has been introduced here, that I can, of course, 10-ton, a single point load applied on a surface. So we can come over here. We won't actually see the load point, but you can see just a simple structure here. Moving on, and as we progress, the different irregular designs come into focus. So you can see here two modules, a single rectangular module with also a trapezoid module connected onto that for a sort of joint design as such. Next one, passage with skewed floor layout. So you can see here the skewed layout with the extended wing walls here. Now, of course, I have the option to amend these bottom supporting slabs. You can see the type of shapes that we contribute. So these are all being attributed from and defined from a actual DWG file that's been provided within the program. Another passage with a irregular section. So you can see the sort of examples show you guys the capabilities of defining here. So you can see the sort of irregular top section that's been defined here. Now this is, of course, can be used for different functions, of course, depending on the application that you guys need when designing. And also a geometry input from a CAD. So here you can see the drawing that represents here, that is represented. I can, of course, view the drawing if I wanted to. You can see here what I mentioned prior, the culvert drawing, the different layers taken from those. I can, of course, change the type of layers that are visible, make those changes. I can select the visible area, of course. So if I wanted to define a different visible area, I can, of course, change the scale, of course, the origin. So I can attribute the origin to that point if I wanted to. Select the visible area of the template. And then, of course, the type of object snaps that I can do. So I can snap to different points, midpoints. If you have used our other software, you would be familiar with the type of snap and the sort of ease of operation when we're dealing with interacting with our drawing files. And that's basically it for the sort of template options. There are some other things, but we don't have too much time to go through them. And of course, that sort of values here. Now I've just played around with the template, and that's just stuffed it up a little bit, but that's fine. Of course, this is a 3D view of that particular box culvert, just a straight box culvert with the regular values here. There was one last one, I'm pretty sure. This is the hydraulic load. So this is when we're talking about water coming into our template. You can see here three modules along with the 4 wing walls connected. We can come over here to the options here. And what was it? Options? No, the general data. And you can see here that I've defined the fill within the project, and also define the hydraulic surcharge here at 2 meters. And we'll actually view that hydraulic surcharge when we go into the 3D view at a point of 2 meters by constant level. If we come over here to 3D view, you'll be able to see the hydraulic surcharge that can be attributed, and that's this particular, that's this shaded area here at 2 meters, which corresponds to the water, the hydraulic surcharge present within this box culvert. Now that's a little bit about the type of projects we can define. Now, in terms of the real functionality here, I can analyze. Now, I can, of course, check. And what this basically does is check the code. You can see here the type of errors. We can select this one here. Some of the checks have not been verified for this particular wing wall. Would you like to view a complete report? Yes. And you can see here, I get a full report on the checks that have taken place on that particular wing wall. You can see our chop transverse reinforcement is not verified, which is pretty negligible by 0.0002, whatever it is. And then, of course, you can see the final thing. So this one has been checked. You can see here the maximum shear has not been satisfied here, so I need to go and define the make amendments to those walls, and of course some soil uplift that's been present as well. So what we can do here, I can come over to analyze, and I can press design or design all. Design all means that it will design all of it. If I press design, I can select the type of the sort of component that I want to design. Right, let's press design all. Let's see how it goes. You can see here it's designing and checking every type of module. You can see that there are some errors that have been attributed already. So now this is a full report on the box culvert here. Starting off with the left initial wing wall and then progressing forward. And you can see all the different types of checks that have been defined. You can see the maximum shear, which basically is negligible, and also another negligible value here. So that's basically the sort of compliance checks that we can do and design capabilities we can define within the program after everything has been defined. I can, of course, share, export, print all these reports in one place, etc. And be able to share those basically with ease at a click of a button. Now, along with the analysis, I can, of course, view the forces. So I can come over here to forces. And we can, of course, look at our force distribution for our design. So by clicking Shift, we can, of course, move around. And view the design from different angles in the 3D view, and also consult the type of displacements that have been formed on our bottom slab. You can see here the maximum value of 3.06. That's defined there. I can, of course, attribute different scale factors. So if I wanted to increase this a little bit, I can, of course, increase the scale, or maybe I'll need to do it by 10. You can see here the type of changes that have been made. I can look at the maximum value and where that operates. I can view the structure alongside the analysis, which personally I don't think adds too much. The form, shape, and also some contour maps as well. So here you can see the type of contour maps, either by displacement or forces. So by displacements, of course, I have the different types of displacements, either by in the X, Y, Z, the total, and also the rotations. So those moment rotations as well. And also forces. So the different forces in the XY axis, the moments, and the shear forces as well. So basically, any sort of analysis that you want to do on the box culvert can be done using our analysis module here. So a very powerful tool. And if you've used our other structural programs such as CYPE for our reinforced concrete structures and CYPE 3D for our steel structures, basically the same sort of methodology where we look at analysis here. So quite a powerful tool as well. I can of course attribute maximum minimum values there and also look at the different load cases as well. So you can see the hydraulic surcharge. I can look at the forces in the Y direction. So you can see, I think this is upside down. That can be attributed to it as well. Now, coming over here, we can of course look at some animations as well. So this is quite a nifty tool as well. We can look at the animation of the load as it progresses. And around those different background colors. What was the last thing we wanted to show was the earth pressures as well. So not only can we attribute the self weight of the structure, we can of course attribute the earth pressure and also the hydraulic surcharge as well. And we can make extra load cases as well within the program as well. So we can attribute different scenarios of use internally within the program. We don't need to look externally for those as well. Now the last thing what I wanted to show was the forces here. I'll come over here. I can consult different types of forces on my structure. So if I come over here, let's go back to 10. Let's go to displacements. You can see I'm able to select different types of nodes within the structure and view the displacements at those sections. So if I had, you can see here, the highest displacement of 0.2 meters occurs in the central portion as expected with a hydraulic load. And that's basically the sort of way we would progress through the analysis of the program. Or we can turn this off, turn that off, turn it off, and okay. Yep. And change the view as well if I wanted to, and also look at some different 3D options if I wanted to with the 3D view. Now return here. That's basically a little bit about the analysis and how we would progress through. In terms of report, just to wrap it up, in terms of reports and drawings, of course, I can look at all these different types of reports that I can define. Let's accept, hopefully this doesn't take too long to define these reports. But basically the same sort of way I can look at generating those types of reports for our takeoffs. You can see here, coded materials, geometry, all the different subsections of the report, and I can view those instantaneously within the program, as well as being able to share and export those quite easily as well. So this is for all the checks. You can see this is still, and we go, an 84-page report on all the different types of checks that have been done on earth pressures, hydraulic surcharges, self weights, top slabs, all the water current values, etc., all internally within the report. And this report basically has everything you guys need to share, export. Now there is a watermark here. That's fine. That's just because I'm using a trial version of the software. So don't worry about that. I can of course attribute the different project values as project details as well prior to initially conducting the report generation. Export, share, you guys know the deal. And then we look at drawings. So this is the where we can actually attribute some drawings here as well. So I have the option to introduce a scale, some text size, dimension sizes, dimensions, and all the different types of details that I want here. Now I'm not going to, well, that's fine, let's just accept the changes. So you can see here, by detailing the drawings, I get a full detail of the drawings, the reinforcement tables, and everything attributed to every component of the structure. So you can see the bottom, the top, the different wing walls, and of course you can edit all these drawings here. So you can use all the editing options here, drawing details, moving objects if you wanted to, look at text implementation, etc. all here. And you can, of course, download these drawings either in DWG format or all the other different types of formats, PDF, etc., all internally within the program, and also attribute those to different values if you wanted to as well. So here you can see the different formats that get taken into consideration.